Welcome to this episode of the CompTIA Tech Plus Prepcast by baremetalcyber.com. Let's begin. Encryption is the process of converting readable information, called plaintext, into an unreadable format known as ciphertext, using a cryptographic key. This ensures that even if data is accessed by unauthorized parties, it remains unusable without the correct key. The CompTIA Tech Plus exam highlights encryption for both data at rest and data in transit, each addressing different security needs. Knowing when and how to apply each type is essential for maintaining confidentiality in IT environments. Data at rest refers to stored information that is not actively moving across a network. This includes files on hard drives, solid-state drives, external storage media, and cloud storage systems. Encrypting data at rest protects it if devices are lost, stolen, or improperly disposed of. Without encryption, anyone gaining access to the storage media could read its contents. Implementations include full disk encryption, file-level encryption, and database encryption, all of which rely on secure key management. Full disk encryption protects an entire storage device, securing system files, applications, and user data automatically. Examples include BitLocker for Windows and FileVault for Mac OS. File-level encryption targets only selected files or folders, while database encryption safeguards structured data within applications. Strong encryption is only effective if keys are stored securely and access is restricted. Compromised encryption keys render even the strongest algorithms ineffective. Portable devices such as laptops, smartphones, and removable drives face higher risks because they are often used outside secure environments. Encrypting these devices ensures sensitive data remains protected, even if physical possession is lost. Organizations can enforce encryption through mobile device management, or MDM, solutions that verify compliance and can remotely wipe devices. This safeguards data against theft and accidental loss alike. Data in transit describes information actively moving between systems, applications, or users over a network. This includes web browsing, email communications, file transfers, and remote access sessions. Without encryption, attackers can intercept or modify data using packet capture tools or man-in-the-middle techniques. Encrypting data in transit ensures it remains confidential and intact during delivery. Transport Layer Security, or TLS, is the most common protocol for encrypting Internet traffic. It is the foundation for Hypertext Transfer Protocol Secure, or HTTPS, which protects communication between browsers and web servers. HTTPS is indicated in the browser address bar along with a padlock icon. It ensures that data such as login credentials or payment details cannot be read if intercepted. Email encryption protects messages and attachments from being read by anyone other than the intended recipient. Secure Multipurpose Internet Mail Extensions, or S/MIME, and Pretty Good Privacy, or PGP, are common standards. These encrypt email content end-to-end, securing it as it travels through multiple servers. This is especially important when transmitting confidential or regulated information. File transfers also require encryption to protect sensitive documents during transmission. Secure File Transfer Protocol, or SFTP, and File Transfer Protocol Secure, or FTPS, encrypt file uploads and downloads between systems. These methods are widely used for exchanging sensitive business or client data across organizational boundaries without risking interception. Virtual Private Networks, or VPages-Ns, encrypt all network traffic between a device and a secure gateway. They're critical for remote work, allowing secure access to company resources over public internet connections. By creating an encrypted tunnel, a VPN prevents unauthorized monitoring of transmitted data, protecting both the contents and metadata of communications. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Encrypting backups is a critical extension of protecting data at rest. Backup media often contains the same sensitive information as active systems, and if it is not encrypted, A lost or stolen backup drive could expose large volumes of data. Full disk encryption can be applied to backup drives, while cloud backup services typically use built-in encryption. For cloud storage, encryption should occur both on the client side before upload and on the server side, with secure key management to maintain control. Key management is central to all encryption strategies. A cryptographic system is only as secure as its keys, which must be generated, stored, and transmitted securely. Keys should be protected using hardware security modules, or HSMs, or dedicated key management systems. Rotating keys periodically, revoking compromised keys, and limiting access to authorized administrators are best practices. Poor key management can result in encrypted data becoming unrecoverable or exposed. In addition to protecting data integrity, encryption can support regulatory compliance. Many privacy regulations, such as the General Data Protection Regulation or GDPR, and the Health Insurance Portability and Accountability Act or HIPAA, require encryption of certain types of data. Using encryption appropriately can help organizations meet these legal obligations and reduce penalties if a breach occurs. Documenting encryption processes also supports compliance audits and risk assessments. For data in transit, advanced protocols provide layered protection beyond basic TLS. Secure Shell, or SSH, is used to encrypt administrative access to remote servers, preventing attackers from intercepting commands or credentials. Internet Protocol Security, or IPsec, operates at the network layer to encrypt traffic between systems, often used for site-to-site virtual private networks. Both SSH and IPsec are essential for securing sensitive network operations. Multi-factor authentication should be combined with encryption for maximum effectiveness. While encryption protects the confidentiality of data, multi-factor authentication ensures that only authorized individuals can initiate encrypted sessions or decrypt stored data. This layered approach significantly increases the difficulty for attackers to compromise both access and data simultaneously. Performance considerations are part of planning encryption use cases. Strong encryption algorithms require processing power, and on resource-constrained devices this can introduce latency. Selecting the right algorithm and hardware support, such as using processors with built-in cryptographic acceleration, helps maintain performance while keeping data secure. Balancing encryption strength and system efficiency is a key design decision for IT teams. End-to-end encryption is another important use case, especially for messaging applications. With end-to-end encryption, data is encrypted on the sender's device and only decrypted on the recipient's device, with no intermediate system able to read it. This protects communications from interception, even if the service provider's servers are compromised. Examples include encrypted chat platforms and secure voice-over IP services. Organizations should also implement encryption monitoring to verify that data is being encrypted correctly. This includes testing configurations, validating that encryption is active during transfers, and scanning storage systems for unencrypted sensitive files. Security information and event management platforms, or SIEM systems, can be configured to alert administrators when unencrypted data traffic is detected. Incident response planning must account for encryption. In the event of a security breach, teams should assess whether compromised data was encrypted, confirm the strength of the encryption used, and verify that keys remain secure. If encryption was implemented effectively, the risk to exposed data may be significantly reduced, allowing a more targeted response. On the CompTIA Tech Plus exam, you may encounter questions asking you to differentiate between encryption methods for data at rest and data in transit, identify appropriate protocols for specific use cases, and understand the role of encryption in compliance requirements. Scenario-based items may require selecting the correct encryption type for protecting backups, securing web traffic, or enabling secure remote access. Glossary terms for this topic include data at rest, data in transit, transport layer security, secure sockets layer, secure shell, internet protocol security, full disk encryption, file-level encryption, and end-to-end encryption. Grouping these by their primary function, storage encryption, transmission encryption, or key management, can help reinforce understanding for exam success. In real-world IT environments, encryption is applied consistently across devices, applications, and networks to maintain confidentiality, meet compliance obligations, and protect organizational reputation. IT teams manage encryption settings, monitor for compliance, and adjust configurations to address evolving threats. Properly implemented, encryption becomes a fundamental component of a layered security strategy. In the next episode, we will explore encryption in practical scenarios by covering data at rest versus data in transit use cases in greater depth, with examples of tools, protocols, and configurations used in enterprise environments. This will prepare you to apply encryption concepts directly in the field and on the exam. Thanks for listening. Please visit baremetalcyber.com for more cybersecurity information and education, including a new children's series. For more information on books and more, follow us at cyberauthor.me.